Hello, this is the review of the week 6, and this video will start with about anti-reflection coating. To understand about the anti-reflection coating, we need some concept of the interference. If there is same phase of wave, there, in this case, the constructive interference will occur, and there's a opposite phase of the wave. There occurs the destructive interference. And we should know about the Bragg's law, and we should focus about this path length distance. When we shoot some light into the photoresist, there will be some reflection. So first, some light will reflection to the surface of the photoresist, and some light will transmission to the photoresist and reflection to this surface. So there will be two reflection. If these two reflection waves makes this constructive interference, it makes some curved patterns called scallop. So we cannot make some patterns we want. So we need to do something to prevent this problem. So that is the anti-reflection coating. So these two methods exist. Is called top ARC and bottom ARC. And this table shows the method of the anti-reflection coatings, and nowadays we often use this method. And the second topic is the phase shift mask called PSM. When the light comes through to the mask, there will be some deflections. So look at this mask. Through this shape of the mask, we can know we want to make these patterns, but when the light comes through, because of the diffraction of the light, this shape of the patterns will made, because the deflections of the light, so light will spread with the Gaussian population. So in this part, make these patterns. So prevent this problem, we use some materials on the mask. This material makes the this material change the pace of the light, so the light come through like this shape, so we can make the patterns we want. So this method is called attenuate phase shift mask. And there's another method, it's called alternating phase shift mask, and this method is we trying to control the thickness of the glass. So by control the thickening of the glass, we can change the pace, so we can prevent this problem. And third topic is about optical proximity corrections. This optical proximity correction is a kind of the mask design that if we want to make these blue patterns, and if we make the patterns same as this pattern, this round shape, this round edged shape of the patterns will made, but this is not the patterns that we want to make. This problem is occurred because of the intensity of the light, so we should control the intensity. So in this area there should need more light, so we make the design the mask more bigger, and in this part there should the intensity of the light has overflowed, so we should make the mask smaller. This is called the optical proximity correction. And next topic is the off-axis illumination. According to these equations, we can notice that if the lights come through like these vertical directions, that means this angle is 0. The deflections of the light will made like this, and we can get some information about these equations. If the size of pattern is getting smaller, this angle is bigger. It means there's more deflection. So we cannot. We need more information about the lights. So to prevent this problem, we're trying to tilt the incident wave angle. If we tilt the angle, the deflection occurs like this figure, so we can get some the higher order. So to compare these two figure, we can know the depth of focus is larger in this case. So by using of the off axis, we can prevent the trade-off problem between the numerical aperture and depth of focus. In this case, the depth of focus is about this length, but if you tilt the incidence wave, the depth of focus will longer than this case. So we can solve the problem of the trade-off. And next slide is about the double patterning process, and there we should use this process because of we have to make more detailed patterns. There's a LALI method and the self-aligned double patterning method. This is the similar method that using the repeated steps of the lithography and etching, but there's some difference, and this table and figure shows about that method. But in the LALI method, the distance between the patterns will be different, so it makes the overlay problems. But in the self-aligned double patterning process, we use some spacer, so we can make some patterns, but in this case, the similar problem will occurs, but the reason of this problem is different. We should know about that. So this is about the double patterning process. So today I talked about the anti-reflection coatings and phase shift mask and optical proximity corrections and the off axis elimination and the double patterning process.